Hello everyone, welcome back to our channel Geomatics Engineering. Here we learn and explore the things related to Geomatics Engineering. So today we are going to start our new module, Photogrammetric Survey. In this, our first lecture is on aerial photography. So let's start. Photogrammetric survey is science and art of obtaining accurate measurement by use of photographs. In simple word, if we will try to explain photogrammetric survey, then it is surveying done with help of photographs. Means we calculate linear measurement, angular measurement by having interpretations over photograph. Photograph can be taken on or near the ground or with help of aircrafts flying over an area. So in this way, photogrammetric survey is classified in two subcategories, that is terrestrial survey and aerial survey. Terrestrial survey is that survey in which photographs are taken from a fixed position on or near the ground. Means cameras were mounted over tripod stands, or phototheodolites means theodolite mounted with a camera is used for with its axis horizontal and near horizontal and keep on capturing photographs. With help of terrestrial photograph, we capture the side view of the image. We captures, for example, we will see the photographs. For example, we will see side view of the height of the object with help of terrestrial photograph. In aerial photograph, photography is done by the help of camera mounted on an aircraft. Not generally aircraft. It nowadays drones are also used, but in general we say aerial photograph is done with help of camera mounted over the aircraft flying over an area. So aerial photograph is very much useful than terrestrial photograph because it provides a large view. And for military intelligence it is very useful. So let's see further types of photograph: terrestrial photograph and aerial photograph. You can see here two terrestrial photographs are shown. It is near range and it is far range. You can, if you want to classify, it is near range and it is far range. This one is captured by a phototheodolite which is fixed over a place far from a mountain and captured the landscape and mountain both. But here a phototheodolite photos is being captured by phototheodolite from near a building. So it is showing a side profile of the building. It is also showing some cars. So this type of details we are getting with help of a terrestrial photograph. Not extra detail we are getting, it is very low details we are getting. So this is why terrestrial photographs are much lesser useful than aerial photograph. In aerial photograph, you can see here large area is being seen. Large area. So it is suitable for inaccessible areas, mountainous regions where we cannot go, mountainous regions. Also, mapping of large areas are faster and economical. If you want to map a city, then just fly a aircraft over it or fly a drone over it and you will get the mapping of the city in few hours only. But there comes some limitations also. There comes some limitations of aerial photograph also, is that you need a skilled person for image interpretation, also for flying and several activities involved in aerial photograph. Also, aerial photograph is not economical when it comes for small areas. For example, if you have to just capture a land, or you have to just capture a patch, a mohalla or a small town, then it will be more costly for using aerial photograph. So there are some advantage and disadvantage. Now moving to the aerial photographic survey, you can see here a flight is flying in this way, and then it came from this way and now it turns to this way and keep on capturing the photographs. Here it is also shown that flight line is this. After keeping keep capturing photograph, then it turns back, keep on capturing this side and again turns back, and the whole area is being surveyed. Now moving further, the basic requirement for aerial photograph. Just there are two basic requirements, that is a camera and a platform. For photography you need a camera. This here a diagram of camera which is being used in old days. Nowadays digital cameras is being used. This one is showing a interior diagram of cameras which is being used in previous days. That is, in this camera you can see this body axis, or we can say camera axis of the camera, which is known as optical axis. Then here comes a lens assembly, this much, you can say this much lens assembly, lens where you can see filter allows a specific wavelength to come and not allowed specific wavelength. Then a lenses, pair of lenses, also a shutter. Then focal length of the camera. Focal length of the camera is the length from optical center to that distance where photos is being captured. Now this one is the negative plane, or we can say film plane, where image is being captured. If someone of you have seen old days camera, at that time some cameras were come, all the cameras were of that type, that in that reels were used. Once the reels got ended, then we have to change the reel. Kodak camera were used to come, that you have to put reels in the back side of the camera, and after reels got ended, then we put out the reel and give it to shop that take the negative, and give that shop, after some days of processing, it gave us photographs from that negative. So this one is the negative of our camera, negative plane. And when photos comes, that comes in the positive plane, if you remember, and if you have seen negatives of old photographs, if your family have some old photographs, then just ask them for negatives. You will see that images are blurred, and also images, compare the negative image to positive image, you will see that images are mirror image. Means if image is like this in positive photo, then it will be like this in negative photo. So just keep see it if you have negative in your house. Now moving further, after aerial camera, next one basic requirement, that is platform. Platform is where cameras are mounted. In past days when aircrafts were not there, then people used pigeons. They mount the camera, they fix the camera over pigeons, and when pigeons, after flying some areas, when they came back, then processing of negatives happens, and then photographs were taken. After that, after pigeons, hot air balloons were used. You can see here a man using something to watch the grounds. Then aircrafts were came into pictures, and then drones. Nowadays drones are used. Here also aircraft, but nowadays drones are also used for aerial photography. You have seen in several marriages party that drones shots have been captured in the marriages and small parties. So in this way drones are also used for the aerial photography. Now moving further, this diagram shows how a camera is being used for capturing the photograph. You can see here optical axis of the camera, it is targeting some area on the ground. The area is not, you are seeing one side view only, so area is in 2D way. This patch of land which is being captured at once is known as instant field of view. Instant field of view. Instant field of view means this much land is being captured at an instant. This is called instant field of view. Also, you can see that this image is being captured here at the negative plane. So at negative plane, a photo is being captured. And after processing, what we will get? We will get a positive photo out of it. It is negative plane. After processing, we will get a positive photo. For example, I am writing here, this is point A, this is point B. So on negative plane, we will get A dash and B dash, like this, opposite of the positive plane. But after processing the negative plane, the photograph we get in actual will be in positive plane. Like this is the positive plane of photograph. Means this will show A, B on photograph. So in this way aerial photographs are taken, and in this way aerial photographs are taken for interpretation, for getting a positive photograph from negative photo. So we use at last positive photograph for analysis and several kind of activities. So here you can see it is the focal length f from the center. Here is our flight. At this point here is our flight and camera is mounted over here. So from flight, here is our flight and camera is mounted here. At a distance f, focal plane is located. Focal plane means negative plane is located. Flight is traveling at a height h. Our undulation, there are some undulations also in the ground. So in this way several kind of calculation is being done. So we will see them one by one. Now moving to aerial photograph. Depending upon the vertical axis of camera, that is camera axis or optical axis, what we are calling it optical axis, there are several types of photograph. First one is vertical photograph, that which says that our vertical axis means axis toward the ground, vertical downward axis, and camera axis is same. If vertical downward axis and camera axis is same, then our photograph captured is called vertical photograph. If there is some angle between camera axis and vertical axis of the ground, then it is called tilted photograph, and in this angle have limitation from 0 degree to 3 degree, means maximum 3 degree and minimum is more than little 0. If 0 degree it will become vertical photograph, and up to 3 degree it is tilted photograph. But if tilting is more than 3 degree, then it comes under the category of oblique photograph. And again in oblique photograph there are two subtypes, that is low oblique and high oblique photograph. Let's understand how these two is being categorized. In both of them tilting is more than 3 degree, but in low oblique photograph, horizon, there is a term horizon is not visible. In high oblique photograph, horizon is visible. Horizon is means what? If you have done it, you will feel it. I am giving an example, try to feel it. That sometime we captured some movement by tilting our camera axis of phone. We either do in selfies or either do in back by using back camera. We tilt some with some angle, and we will see in photograph that large distance, especially in case of when we are taking photographs of sea or skies, we will see that large distance is being captured. Large distance is being captured, which is not accessible or very near to us, but at very far from us is being captured. So that large distance which is very far from us is called horizon. If it is being captured, then it is called high oblique photograph. Otherwise it will be called low oblique photograph. We will see them. In low oblique photograph, only side profile of object is being captured. Tilting is such that only side profile is being captured, so it is called low oblique photograph. We will see some photographs and you will get an idea what is horizon. So let's see. Here optical axis of the camera, or we call camera axis, is at 90 degree. So if it is at 90 degree, then photograph is obtained vertical photograph. Here little and tilting is done here. Low oblique photograph is shown here. You can see the side profile of bridge here. Here you can see side profile of bridge here, but not very far from bridge anything is there. You can't see that. Only side profile of bridge and little bit of river surrounding it, you can see it. So it is low oblique photograph. Now moving to next photograph, this one. This is the same bridge you have seen in previous photograph, and you can see that not only the side profile of the photograph, you can see the river, also you can see a mountain which is very far from it, very far from it. So this is called horizon. This is called horizon. You can see the horizon also, which is very far from it, which is very far from it. So in this type of photograph, it is called high oblique photograph. Here also are two photographs of same place at the same time. That is a hurricane. After hurricane, a photograph analysis is done. It is a vertical photograph. You can see top view of everything, and it is in side profile with help of low oblique photograph. So these are the some examples of aerial photograph. Now moving further. Now moving further to next and most important part of our video, that is scale of photograph. Scale of photograph. Now I must say that this module will consist of 2 to 3 videos or maybe 4 videos, but I will say after seeing these 4 videos you can achieve more than 5, around 5 to 10 marks, 5 to 10 marks in your exams. From now, this is up to theory is up to this only. From now we will see numericals depending upon scale, relief, displacement, parallax, everything, and with help of those numericals, you can achieve 5 to 10 marks in your GATE exam. So this one is going to most important and most short and most productive part of your syllabus of geomatics engineering. So let's start. First one is scale of photograph. So here we have already seen that positive plane and negative plane. Let me go back to that slide. Here we have already seen negative plane and positive plane of photograph. Positive plane is nothing but just the same triangle we have created here and photograph. The dimensions are same. So we can say that this triangle and this triangle is same. So let's try to understand by making a figure, and then we will start scale of photograph. So see this figure. Let's assume it is point A and point B on ground. Its photo is being captured on negative plane. A dash, negative plane A dash and B dash. So we have to process it and make a positive photo out of it. So we have processed it and make a positive photo like this on positive plane. Plane B and A. So this AB represent our photo distance on photograph, and this capital AB represent our distance on ground. And we have known that in map, scale is what? Scale is map distance upon ground distance. So here scale will be what? Here scale will be photograph distance upon ground distance. So here photograph distance is AP, and here capital AB. If we are talking about two points, then AB and capital AB. If one point, we will see that also. So just keep in that mind that in this way negative plane and positive plane works. Now we will see and calculate scale of photograph. So let's start with the calculation of scale of photograph. So as per definition, will be equal to distance on photograph upon distance on ground. So we will calculate for point A, here point A and point B separately. So for example, let's start with point A. Pay attention from here now. Point A. Here A not A. Ground distance is, I am representing it with GD. Ground distance is A not A. This one, A not A is the ground distance, ground horizontal distance. And distance on the photograph plane, positive plane. Here positive plane is shown by this line. Positive plane. Distance on photographic plane of positive plane is this PA. Photograph distance is PA. So scale will be what? Scale will be distance on photograph upon distance on ground, that is PA upon A not A. Now look in triangle OPA small a and triangle OA not A. Now see in these two triangles, you will see that this angle will be equal to this angle. This one is the 90 and this one is the 90, and this angle is the common angle. So by angle similarity, these two triangles are similar. If you don't know what is similarity, if three properties of any two triangle matches, then triangles are called similar, and then ratio of their corresponding sides equals to ratio of others corresponding sides. So now here by angle similarity, these two triangles are similar. So we can say that here OP will be equal to OP upon this one, this height OA naught will be equal to PA upon A naught A, and for scale we required this only, PA upon A naught A. So let's calculate OP and OA naught, and we will calculate the scale. Here OP is what? We know that photograph is captured at a distance of focal length from the center. So this is the focal length F. So OP we have calculated is equal to focal length F. What is OA naught? So for OA naught, we have to see height of the flight. Flight is here. At what height flight is flying? It is H from the datum. Datum means mean sea level. From mean sea level, flight is moving at a height of H. And point A is at a height of HA. Point A is at a height of, means RL of A. RL of A is HA. So what will be the height, this one, OA naught? you can easily see here OA naught is capital H minus this HA. So by calculating this, we can say scale will be equal to PA is equal to OP, that is F upon A naught A, that is OA naught, that is H minus HA. So this comes up scale for point A. Why I am calling point A? Why I am not saying that for point B this scale is also same? Because you can see in formula of scale A, what we have derived here, focal length of the camera will be the same. Height of the flight at which flight is moving, aircraft is moving, will be same. But height of the point from mean sea level will be not same for every point. RL of each and every point will be different. It is not necessary that RL of every point will be same. So here HA will be not same for every point. So point A, for point A it is HA, so it is F upon H minus HA. But for point B it is HB. You can see here also for point B it is HB. So if you will use this triangle and this triangle, you will calculate different value of a scale. So here additional information comes up that scale of photograph, scale of aerial photograph is not same for all point. First point we are come to know this. Now next point. For next point, let's see here. For example, if we are talking about a plane which is little undulating. Little undulating means undulation of Earth's surface is very less. Every point is at a same height. For example, we are talking about a plane which is having all the point at a same height. So at such case what will happen? HA equal to HB. Every point will be at the same height. Then in such case HA equal to HB equal to HC, and for all the points their RL value will be same. Then in this case scale will be same for all point. Now if in any case, for example A and B point height is not given and given average terrain height is given, then what you will do? In such case average scale is being calculated, and average scale will be represented by F upon H minus H average scale. In that type of question, average scale will be calculated. And for example, another type of question comes that give me the datum scale. So what you will write down the value of H, small h here. For datum means there is some point which is lying on the datum, and for datum this height HA or HB what we are writing here is 0. So for datum, scale will become F upon H. So in this way, scale of photograph is being calculated. So we will do questions also in next video. Before that, try to understand scale of photograph from this video. It is very important. Just by applying similarity concept of triangle, we calculate the scale of photograph, that is F upon H minus HA. Here F and H are same for every point, that is focal length and height of the flight. But RL, or we call it height of any point, is different from point to point. So scale is not same for any terrain. Any terrain scale is not same for all point. If all point in question if given is that terrain is very less undulating and all points are at same height, that means HA equal to HB equal to HC. In that case we can say scale will be same for all point. For example, average height of the terrain is given. Average height of the terrain means HA, HB, HC is not given, but average height of this terrain is given. In that case we can calculate average scale of the terrain. And also if datum scale is asked, then H average becomes 0 and you will calculate the datum scale F upon H. So this is all from today's lecture. In next lecture we will move on further. If you have any doubt regarding scale of photograph or terrestrial photograph or aerial photograph, just comment it below, because this portion is very important for your GATE examination. So till then, take care, bye bye, have a good day.